Whenever Elon Musk talks about the future of Tesla's humanoid robot Optimus, he often draws comparisons to characters like C-3PO or R2-D2 from Star Wars. He envisions a world where every person has their own personal robot. But while Tesla continues to release more impressive upgrades to Optimus, it's also sparking mixed reactions. Let's be honest, not everyone is thrilled at the idea of lifelike robots walking among us. Many fear a dystopian, Terminator-like scenario where robots become too powerful, potentially replacing us or taking our jobs. But that's not what Musk says he's creating. According to him, Tesla aims to manufacture billions of these robots, not to replace us, but to solve labor shortages and free humans from repetitive, mundane tasks so we can focus on creative, meaningful work. In recent months, Musk has rolled out a series of updates that show just how quickly Optimus is evolving. Each version moves better, becomes more agile, and handles tasks with greater finesse. One particularly exciting improvement is its newfound ability to manage unpredictable, dynamic movement. That kind of adaptability is critical for real-world jobs, whether in homes or factories, where conditions can change moment to moment. Today's highlight? Optimus' insane balance. Now, that might sound like a small thing, but balance is everything. It could be the deal breaker for whether someone actually wants to buy one. Nobody wants a robot that stumbles after a few steps, or worse, one that knocks over dishes or furniture with a clumsy gait. Balance is crucial. Without it, a robot can't do real work. Developing humanoid robots with solid balance is incredibly challenging. Unlike wheeled robots or stationary machines, humanoids have to mimic how we move, on two legs, in a 3D space. That requires sophisticated coordination between hardware and software, along with the ability to adapt to varied terrain, from smooth indoor flooring to uneven outdoor surfaces. A robot with poor balance becomes a liability. One fall could damage its parts, interrupt its task, or even pose a safety hazard. And if it can't keep stable, it can't perform more advanced movements like climbing stairs, carrying items, or maneuvering through complex environments. Strong balance is critical in every scenario. In factories, a robot might need to walk over cluttered floors, cables, or debris. In homes, it might be climbing stairs, stepping over objects, or staying upright if nudged. In disaster zones, it could be balancing on rubble to reach someone in need. Without top-tier balance, robots simply can't be relied on. Take Boston Dynamics Atlas, for example. Their acrobatic displays earn praise because they show off exactly this: agility and control. Now, to appreciate just how far Optimus has come, let's rewind to two key videos. The first dropped in December 2024. It showed Optimus walking up and down a steep, gravel-covered hill. Sure, its gait looked awkward, like a drunk guy struggling to stay upright, but the achievement was massive. That slope was covered in mulch, and even Tesla VP of Engineering Milan Kovac admitted he slipped on it. Yet Optimus handled it with surprising poise. It even slipped slightly, but caught itself using limb reactions that looked surprisingly human. What's more, Musk confirmed Optimus was in blindfold mode during that test, meaning it couldn't see the terrain at all. That makes it even more impressive. It relied purely on internal sensors and neural networks, reacting in real time to each change in ground condition. Then came the second video, where Optimus danced, ballet spins, street-style moves, and fluid motion, all on the factory floor. It wasn't just a fun display. It was a demonstration of real control and balance. These movements involved rapid shifts in the robot's center of gravity, yet Optimus stayed upright the entire time, completely unsupported. This showcases how advanced its sensors and software have become. From coordinated motor outputs to real-time motion calculations, Optimus is proving it can stay balanced, no matter the action. So, what's making this level of control possible? It starts with hardware. Optimus has an inertial measurement unit to track motion, and force sensors in its feet to detect pressure and friction. These allow it to walk more naturally, especially on smooth surfaces like factory floors. High-powered servo motors give its joints the agility needed to make fast corrections on the fly. What makes this even more impressive is that everything in these demos is untethered. No cables, no stabilizing rigs. Optimus balances on its own. On the software side, Tesla's real edge lies in its AI. Optimus uses the same neural network foundation that powers Tesla's self-driving vehicles. According to Milan Kovac, during the hill climb, Optimus didn't use visual input. Instead, its AI predicted terrain shifts and controlled limb movements based on real-time feedback from body sensors. This means that even without working eyes, Optimus can feel and react to the ground beneath it. Its feet read textures like dirt or gravel and send that data to an onboard AI brain, which processes it instantly, just like a human adjusts while walking across unfamiliar terrain. Tesla calls this real-world AI, and they're pushing it even further using their Dojo supercomputer, electric motor designs, structural engineering, and in-house manufacturing expertise. When Optimus climbs stairs, it does so autonomously. Built-in sensors analyze step height, angle, and surface grip. In just a few milliseconds, its neural net figures out how to shift weight, where to plant each foot, and how to avoid slipping. This results in stable, reliable movement, even if not quite human-level fluidity yet. What's amazing is how this skill is trained. Tesla runs millions of simulations, covering every staircase type you can think of. This dramatically reduces the need for physical trial and error and accelerates training. And yes, descending stairs is even trickier, but Tesla is working on that too. The robot is learning to keep its center of mass low and respond fast to gravity's pull. Kovac also shared that they're developing safe falling skills. Sounds strange, right? But it's logical. If Optimus falls, it needs to do so in a controlled way to avoid damage and be able to get back up quickly. Ultimately, Optimus balance is what makes it viable in real-world settings, from manufacturing to home assistance to search and rescue. In factories, it can carry tools, assemble parts, or navigate tight spaces without dropping or damaging expensive components. At home, it needs even more precision. Whether it's helping the elderly, handling fragile objects, or simply walking around, any imbalance can cause damage or worse, harm. A single mistake could hurt Tesla's brand and customer trust. In this space, safety isn't optional, it's essential. In emergency situations, disaster zones, space missions, or even the military, robots need rock-solid balance to handle unstable terrain. A stable robot not only performs better, but avoids becoming a liability in critical moments. Tesla's second-gen Optimus packs a 2.3 kilowatt-hour battery, giving it around 8 hours of operation per charge, enough for a standard shift. But actual usage time varies. Tasks like walking or lifting reduce battery life, while more stationary work extends it. Optimus' improved posture and energy-efficient movement help stretch those hours, thanks to AI-driven coordination and lightweight materials like plastic and carbon fiber.